Next up, we're adding the classic topo maps to Google Earth. Go ahead and click this link. If you don't have that link, Google that same text and it'll show up. It's a ArcGIS image server that allows you to access this. And it's going to download. See, I've done this 3 times, but I'm going to go ahead and click on that. And that, if I have Google Earth open, will open up as you see here. Might take a little while because it is beaming that in through the internet. As you scroll in, you'll see these maps change their resolution. It's accessing different sets of maps created at different scales. Those different scales have different resolutions of data. As you zoom in farther, you'll see more small streams, more small ponds, more small features. When we were farther out, we saw only the larger features. So we're zooming right in on Katahdin here, getting up on the one you've probably seen, and I believe this is the 1 to 24,000. Something you'll notice here is these 1 kilometer by 1 kilometer grids are all warped and twisted. That's because Google Earth is trying to display terrain in sort of a 3D way. It's awesome when you're working with air photos. You can even see where the steep gullies are by moving the screen around. I'm not going to do that now because it can be kind of dizzying if you're just watching it. But it's not showing this 2-dimensional map accurately. So I'm going to go down here, uncheck terrain. See, that snaps everything to a square grid. Now that we've got this map squared away in a 2-dimensional view, let's go ahead and measure these, in theory, 1 by 1 kilometer grids and see how that lines up after we've converted them into a digital format and brought that into Google Earth. So I'm going to do my best to hit the middle of one line and the middle of the next. 1003, 1000.9. I think we're looking pretty alright on that front. And looking down here, we can just barely make out 4,500, 4,600. That's got to be 4,700 here. These are contour lines, showing lines of constant elevation around here. So if you were to walk along that line, you would neither gain nor lose elevation. And we can see this Hamlin Ridge here. That U shape is descending the ridge. And these sort of V shapes here and here, more pronounced down here, are showing a river cutting into the hillside. We can count that these large, heavy contours are every 100 feet, and we count 1, 2, 3, 4, 5, so these are 20-foot contours in between. So here around Klondike Pond, we can see a ridge coming down here, and then a stream cutting in here. Over in the Northwest Basin, we have a ridge here, another ridge line coming down here, we have a stream cutting in here. As we go down this ridge, we see it's steeper here. The contour lines are closer together, which means you're changing elevation faster. Here, nearly flat, and this little line here, completely enclosed, that's actually gaining elevation again. It's called a promontory. So you're going down that ridge, you're going down, 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 flat, then back up. And then you're going down again, down, 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 down. You have another promontory here. So you have a relatively gentle walk down here, but if you were to walk down here, you might in fact be falling. How steep is it? Rise over run. Let's go ahead and set our distance to feet. We know from one thick line to the next thick line is going to be 100 feet in elevation change. Let's go ahead and grab our calculator here. So our rise is 100 feet. Our run is 364. Our slope is 27%. Versus our slope going down the ridge here. Let's go ahead and measure that distance, if it'll let me. From there to there, 1,605 feet. And our rise, again, 100 feet change in elevation. So we have 100 divided by 1,605. 6% grade. So 6% grade going this way, 27% grade going this way, so you definitely want to take that walk over that trip and fall. We have another stream cutting into the hillside here, another one here. We have some V's pointing up the hill here, which suggests some kind of a stream, or in this case rock slide, because we are on Katahdin. Now being in Google Earth, we can just uncheck our topo maps and take a look at the air photo. And I would think that this would be an ephemeral stream, carrying meltwater off the mountain in the spring. And there's an awful lot of snow that falls up there, and it's all got to go somewhere, and it goes that somewhere in an awful rush in a very short period of time. So I would buy that, but I would want to go take a look at it before really committing to that as the cause of this V pointing up the hill, which must have been here for some time because these maps aren't new. Here's an interesting spot where the stream is flowing down, 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 down here. We have Little Hawthorne Pond, it looks like, if I'm reading that correctly. We have this other stream cutting through here. And right here is the divide where Waterport here will flow down over the land this way. Waterport here will flow down over the land this way. You can see this is the same elevation here and here, the same contour line. So this one goes all the way around the hill, all the way around the hill, all the way around the hill. And that's the same elevation here and here. So somewhere right between here, there's a boundary line where if you turn to your left, the water would flow this way. If you turn to your right, the water would flow that way. Here on this peak, we see we go down in elevation, and that small enclosed circle there indicates we've gone back up. So this contour line and that contour line are going to be the same. So that'll be 1,000, 1,020, 40, 60, 80, 1,100, 20, 40, 60, 80, 1,200. So that'll be 1,220, 1,220, 1,240 feet. Here's another good place to look at the steepness with contour lines. So we see the lines very closely spaced here, very steep, nearly flat here, and very, very nearly flat here. And we can also see this is where the stream is supposed to be, but on very flat ground like that especially, and on different ground as well. But on very flat ground, you very often get these meandering streams, where this year the channel might be over here, that year the channel might be over here. This year a beaver might build a dam, or the spring freshet might drop off logs, make a log jam. Any number of things could happen that would reroute this stream, and being in such flat ground, it can really go anywhere it wants to. So practically speaking, you would not want to build a road through that, and you definitely wouldn't want to go hiking through there without bug spray. This is another thing we can use our old imagery for, so keep an eye on this part of the channel here, where it looks like the majority of the flow is going down that way. Move that slider all the way up. It looks like the channel is now moving most of its water over here, and this has been filled in. So now that we're zoomed in, we can't really go back 1 year at a time, but we can go back from this photo in 2013 to 2011, 2007, and it looks like we're seeing some change there, but not the change that moved it from over here to over here. 2007 earlier, 2005, looks like we have most of our flow going down here. Maybe some connection there, but not much. All the way back to 1997, it looks like that is the main channel then. Here's another spot just up the stream, so keep an eye on these sandbars here and here. So go back to 1997. So the old channel was here. We have sandbars here and here as well. But as we move forward, let's see, it looks like between 1997 and 2005, this got cut off. So probably some strong spring freshet just blasted straight through there instead of taking that curve around there. And since then, that's filled in with vegetation until it looks like that stream is just where it is. But we can also see that developing a bit, where some of the water is going up here. There's a lot of wood piled up against here, but the water is also taking several routes down through here, trying to get to lower elevation here. Similar here, we have a flow coming through here, the old channel shown here. If we go back to 1997, you can see the water is all flowing this way, but it looks like there is a line here, and it looks like water does pass through there. So one way or another, this might have been a smaller channel or an old channel. It might switch back and forth between these year to year. But let's move forward and see when that happened. So it looks like we're still flowing here in 2005. That channel exists, but as we move forward, 2005, still there, 2005, still there, 7, 11, by 2013, It looks like we've pretty well cut this off completely. There is some water still holed up here, but it looks like we're following what used to be a smaller channel has now become the main channel. And here's one more. Keep an eye on this small channel here. The main channel seems to be this one here, moving forward, forward, forward. And here's a good thing to notice here. So you see how it claims to have been moving forward to 2005. It's referring to this up here. This has not changed. This is still the 1997 imagery. So that's a bit misleading right there. So watch out for that when you're working with Google Earth. Forward again. So we see we still have some water here, but the main channel is very definitely here up to 2005. 2007. 2007 again. 2011 we may have split by now. Looks like we're potentially sharing there. And then by 2013, it looks like we've got a whole bunch of water flowing here and less water flowing through here. So this has come from being sort of a backwater to the main channel. And here's one more spot. Keep an eye here and here as we go forward to 2016. So we have a new channel blasted through there and some connection there that wasn't there before. So moral of the story in all of this, water is incredibly powerful. When you're doing a buffer off a stream, you have to know where the stream itself is, not where it was, not where it's marked on an old topo map.